Greetings grade 11s, welcome. In this video we are going to cover the quadratic patterns. I'm not going to take long. I'm just going to show you what is important in this topic. Now, quadratic patterns, you have to know the general rule first of a quadratic pattern. It is represented by Tn. It is represented by Tn is equal to an squared plus bn plus c. Those of you who knows a quadratic function or graph, you know that a graph is f of x is equals to ax squared plus bx plus c. So in terms of patterns, we are in replacement of x, we talk about n, the variable n. So it's an squared plus bn plus c, where n represents the term number. Term, we are talking in terms of terms. Term number one, and our terms starts from 1 up until infinity. So there's no term number 0. It's term 1, 2, 3, and there are no decimals also. So n is the element of natural numbers, if I can just put it in the correct way, natural numbers. So let me show you the quadratic pattern. So let's say T1 is equals to a, in replacement of n you put 1 squared plus b into 1 plus c. Then our first term in terms of ABC will be a plus b plus c. Then term number 2 will be a into 2 squared plus b into 2 plus c. Then you will have 2 squared is 4. 4 times a is 4a plus b times 2 is 2b plus c. Then term number 3 will be a into 3 squared plus b into 3 plus c, which will give you 9a plus 3b plus c. Of course, term number 4 will be, can you see the pattern? 1, 4, 9. It will be 16a. 1, 2, 3 plus, it will be plus 4b, then the c will remain c. Just like that. So let me just show you the differences. First term is a plus b plus c. The second term will be 4a plus 2b plus c. The third term will be 9a plus 3b plus c. Then the last term 16a plus 4b plus c. Then when you want to find the difference between the two consecutive terms, you are going to subtract the term ekopili le komora. We're going to say term number 2, this is term number 1, term number 2, term number 3, term number 4, just like that. So term number 2 minus term number 1, term number 3 minus term number 2, term number 4 minus term number 3, just like that. So I'm just going to do it somewhere separately. It's going to be 4a plus 2b plus c minus a plus b plus b plus c in brackets, because it's more than 2 terms, more than 1 term. So more than 1 term, then you have to include brackets when you subtract. So it's going to be 4a plus 2b plus c minus a minus b minus c. The sign changes, sorry. Then it's going to be 4a minus a, it will give you 3a. Then 2b minus b will give you plus b. Then the c will cancel the c. Then it means the first difference there will be 3a plus b. Then the second one, you can just do it like this. 9a minus 4a, which will give you what? It will give you 9a minus 4a, it will give you 5a. 3b minus 2b will give you 1b, which is b. Then c minus c will give you 0. Then just like that, 16 minus 9 will give you 7a. 4 minus 3 will give you 1b. Then the c, 0. Then these terms are not the terms, they are not constant. They're not the same. So you continue. You find the differences between the two terms. Then also, yes, 7a minus 5a will give you 2a. b minus b will give you 0. Then you don't write anything there. 5a minus 3a will give you 2a. b minus b will give you 0. Then you see there's something happening here. These terms here are these terms are constant. So the main idea with quadratic pattern is that you have what is known as a second difference. You've got what is known as the second difference. You've got the first difference and the second. So this one is the first difference. This one is the second difference. So the second difference is constant. Twana is constant. That is the main idea behind the quadratic patterns. So let us look at the following example. And remember, guys, they won't ask you to prove this. I wanted you to understand how the quadratic patterns works. So let us look at the first example. Let's say they gave you a pattern. Consider the pattern. They gave you 4, 7, 12, 19, and so on. First question, they say to you, write the next two terms. Write the next two terms. Now, what you're going to do, please make sure you do this. 4, write it 7, 12, 19. Then remember, you must find the differences. 7 minus 4. You say, remember I said to find the difference, minus 7 minus 4, you will get 3. 12 minus 7, you will get 5. 19 minus 12, you will get 7. These are not constant. So you continue. 5 minus 3 is 2. 7 minus 5 is 2. Now you have a constant difference. Remember, it's a quadratic. Immediately when you have the first difference and the second difference, it's a quadratic pattern. Then, how are you going to get the next terms? You continue. Remember, it's 3, 5, 7, then it will be 9 here. 9, it will be 11 there. Then you're just going to say, remember, 12 plus 7 is 19. 19 plus 9, it will give you what? 19 plus 9. Then you've got 28 there. Then 28 plus 11. Guys, how you add? So don't make a mistake. So 28 plus 11. Then you will get 39. Those are the next two terms. 28 and 39. Then the second one, they want the general rule using Tn is equals to the one that form a Tn, general rule. So the most important thing, remember, you must write here. Oh no, this is my 2a. Remember from the proof. The second difference is your 2a. Then here it's your 3a plus b. Remember. Then the last one, it's a plus b plus c. This one is a plus b plus c. Now, you start solving for a first. Ne? That is the most important thing to do. You are going to say 2a is equals to 2. You equate to the first number. 2a is equals to 2. Then you divide both sides by 2. It cancels. Then a is equals to 1. Then you are done. Then you move to b. Still, you say 3a plus b. You equate to the first number there, which is 3. Then you already got your a. Then it's going to be 3 into 1 plus b is equals to 3. Then it's going to be 3 plus b is equals to 3. Then you transpose, or you use additive inverse. Then b is equals to 3 minus 3, which is 0. Then the last step, you equate that to 4 to solve for c. So it's going to be, let me write it here. So it's going to be a plus b plus c is equal to 4. Remember 4, the first term there is 4. Then your a is 1, your b is 0, then you solve for c. Then you equate to 4. Then c is equals to 4 minus 1. Then c is equals to 3. Therefore, Tn is equals to, remember it's an squared plus bn plus c. Your a is 1, so it's going to be 1n squared. Your b is 0, 0n plus 3. But you don't have to write 1 and the 0, so it will be in such format. Tn is equals to n squared plus 3. That is your general rule. To prove that it is correct, just put 1 in replacement of n, or put any number to see if it is correct. I will just say, just using a calculator to check. Let me just check term 2. T2 is equals to, in replacement of n, 2 squared plus 3. 2 squared is 4 plus 3. Then 4 plus 3 is 7. Let me just check. Term number 2 is 7. Correct. Term number 2 is 7 in my pattern. Then I know this general rule is correct. Then lastly, they can just ask you to, this is the general rule. It will help you to find any term of the pattern. They can say to you, find the 30th term. It will help you to find the term still khagala that you won't be able to find while extending this. You can't just keep on going to the 30th term. It will take you long. So let us use the formula to find the 30th term. So it's going to be T30 is equals to, in replacement of n, you write 30 squared plus 3. Then you punch in your calculator 30 squared plus 3. Then term number 30 is 903. Then you are done. Then they can also say to you, which term they want n, which term will be equal to 1684. Which term they want n, which term they want n, term number, they want the term number that will be equal to this value. So when they say which term, it means this thing is your Tn. You write the formula. Tn is equals to n squared plus 3. You write the general rule that you got, that you previously got, and then you're going to write 1684 is equals to, then your n squared plus 3. Then you just do simple algebra. You use additive inverse. So it's going to be 1684 minus 3 is equals to n squared. Then it's going to be 1681 is equals to n squared. Then square root both sides. N is equals to the square root of that, which is 41. Yeah, akuna plus minus. It's only the positive value. Remember why I said n is the element of natural numbers, not integers. Natural numbers 1, 2, 3 up until infinity. So there are no negative numbers here. And when you get a decimal, when you solve for n, it is not applicable, or you made an error somewhere. You must get a natural number. A natural number. Good. That's it about the patterns. And then they can say to you, they love this question. Let me just do it some out loud. Which term will the pattern have a maximum? It's a minimum, sorry, not a maximum, a minimum. Now, ladies and gentlemen, remember quadratic functions. When you have a smiling function, you have a minimum. When you have a frowning function, you have a maximum. So remember, and when your graph is smiling, it's the positive a value, positive one. When your graph is frowning, then you have a negative a value, a value. So our a here is 1. Then it means our graph is in terms of graphs, our graph is smiling. So we will have a minimum. Now, when they mention that, it means they are talking about the turning point. So you must find the x value of the turning point. But now we don't have the turning, we don't see the turning point, but you have to take it in that picture. You have to picture it like that. So we're going to say n is equals to minus b over 2a. Remember that formula when you calculated the turning point. X is equals to minus b over 2a. But here we're going to use n, which is minus, the b is 0 over 2, then the a is 1. Then I know it will be 0. Then you substitute this into the original function, then t 0 is equals to 0 squared plus 3. Then it will be 3. So term number 0 will be our minimum. So I hope it is clear. But I will do some videos with regards to the minimum and the maximum of the patterns. But the important thing was to just note the how to find the next terms, how to find the general rule, how to find any term, and also which term will be equals to a certain value. So thank you very much.